Hey devs, this is the youth DevRel engineer at Mantle. Hoping you're redirected to this video after going through tech tutorial blog that was just published. If not, no worries. We'll be covering each and everything in 3 short videos. In this tutorial, we'll be writing and deploying a non-fungible ERC-721 smart contract using Ethereum and also IPFS, which will be done using Pinata. We will be deploying the contract on Mantle Testnet, obviously, and then also play around with its metadata to give and also bring the NFT to life. And yes, like NFT will be owned by you, and you will also be able to view it on your MetaMask wallet. So yeah, like without any further ado, let's dive right into it. And also, of course, if you have any questions at any point, don't hesitate to reach out to the DevRel team on the Mantle Discord. Links will be in the description below. Again, part 1 of this video, we will be deploying the contract and creating the contract, obviously. Minting and viewing will be in part 2 and 3, right? So I will just quickly share my screen and we can get started. But then before that, there will be a few prerequisites as well. Yeah. I think my screen is visible. We should be good to go. Let me just check. Yeah. Okay. Everything looks good. Let me just check if I'm recording. I think yeah, we are recording. Cool. I think the first thing is to just open. We'll just open a new terminal, open any sort of IDE that you like. We'll go with VS Code for this one because it is very quick and fast, and also I'm quite familiar with it. Yeah, so the only prerequisites will be that to get started with this tutorial, that you have to ensure that you have both Node.js and NPM installed in your local machine. Make sure to follow the tech blog along with this video so that it will be very easy for you to just copy the code and then paste it and then go along. But then even before, let me just check as to let me just zoom in to my terminal. Okay, we are on my terminal, and let me just check as to what is there ls. So we go to projects, cd projects. Cool, we are in projects. Let's see what is there. We already have my NFT, so let's try Mantle NFT. So it'll be cd Mantle NFT. Okay, let me just ls. Okay, so it is in there. Okay, we have to create it. So we just write mkdir Mantle NFT and cd Mantle NFT. So if you're just doing it the hard way, you can directly go to the folder and then manually create the folder and then make sure that terminal opens in your folder directly from it. We're just trying to do it directly from the terminal or the console. You don't have to do all this, right? Now, what we've done is that we navigated to our main directory where we wanted to create the project, and we just wanted to make sure that we are possibly avoiding any overrides. Now what we'll do is we'll type npm init-y, which is a command used to initialize a new Node.js project and create a JSON file package. Let me just do it, and let me just also tell you as to what is the JSON file, right? Cool, I think that is done. So package.json file is basically a config file for the Node.js project that holds info about the project. It will have things like project's name, version, description, dependencies, and scripts, right? Now that our project is created, we have installed the dependencies. Now what we have to do is we have to install Hardhat. Hardhat is a development environment that is used to compile, deploy, test, and debug smart contracts. It helps developers create dApps locally before making them live on chain. So in your terminal, you have to type these commands next, right? I'll also tell you is also like we are using Hardhat, ethers, Pinata because we were getting a lot of requests from the community to sort of use Hardhat for the various uh, uh, configuration as well, how as to how the configuration is basically done with the Mantle Testnet. So we just wanted to clear that bit out. Yeah. So all we do is npm install Hardhat, right? And then save dev Hardhat. So what are we doing over here? So npm install save dev Hardhat is a command that is used to install Hardhat Ethereum development environment as a developer dependency for that Node.js project, right? Save dev Hardhat. I think that looks good. We'll wait for a little while till the time it is done. Um, Installation is completed. Once the installation is actually done, we will type npx Hardhat, which is a command that is used to run Hardhat project. And basically, after that, we are also going to write npx Hardhat test, where we'll check if everything is working perfectly. So yeah, let's do that. Once the installation is done, we'll wait for it to get installed, and then we'll dive right into it. Cool. Now we type npx Hardhat. Okay. Now this is movable, or what do you say? Scrollable. Not, I don't think scrollable is the right word as well. But then you can use your arrow keys to navigate. Yeah, navigate up and down. So we are dealing with JavaScript for this one. We are using JavaScript. So we'll click on enter. You can directly say create a JavaScript project. Enter. Um, Projects Mantle NFT looks good. Enter. Yes. Yes. Cool. So basically, what we did right now was npx Hardhat is the command that is used to basically run the Hardhat in the project, right? Uh, and we also uh, wanted to make sure that it is JavaScript because we'll be using JavaScript in this project rather than TypeScript. Waiting for this to get installed. Once this is done, we'll be again repeating. We'll be using npx Hardhat test, which basically lets us check if everything is working properly. Npx Hardhat test. 9 passing, 3 seconds. Okay, everything looks good. We have check marks everywhere. Cool, nothing to worry about. Now that we have our Hardhat development environment successfully configured, next step is to actually install OpenZeppelin's contract package. This basically gives us access to ERC 721 implementations, which is the standard of NFTs. And on top of it, we will build the contract. Why are we doing this? Because it makes the development very much faster. And also we need to get this part one done as in short time as possible. So yeah. So we write npm install open, wait, open Zeppelin. I think the spelling is correct, slash contracts. Open Zeppelin. Yep, I think it is good to go. Cool. Now you can see on the terminal, it shows 8 vulnerabilities, 5 high, 3 critical. I think for now we can ignore them. We will try to solve them if let's say there are some issues in contract deployment. So coming to contract deployment, we will be using Solidity to write a contract. So we navigate to contracts folder and then create. Okay. So one of the things is that now that we have already done this, what we can do is just click on open projects, Mantle NFT. This is the one, open. Cool. It took me to a new window and it gave me a new terminal. We can kill this one. Um, cool. Yeah, I was just confused for a little while because I was just seeing, because whenever you right click on it, it is supposed to give you an option to open integrated terminal. It wasn't popping up, so I had to do it through the command prompt. I mean, to the command palette, sorry. But then, yeah, we're good to go. So we installed our Open Zeppelin contracts. Now, what we do is we navigate to contracts folder. Contracts folder, we have a file called mynft.sol. Let me just go there. Yeah, we actually don't have it. We have to create it. So what we do is we create a new file which is known as mynft.sol. This looks good to me. And then we add following code to it, right? So one of the first things we do is, okay, I think we can leave that one, but we can, as and when I code, I can let you know as to what I am doing over here, right? That is a better approach. Um, Let me just check if everything's good. I think it is. So what we do is open Zeppelin slash contracts slash token slash ERC721. But even before that, let me just check is to, yeah, so this, yeah, so we're doing it actually correctly. Uh, Obviously, we'll add the semicolons later, but then I was just quickly having a look as to if we're doing it, uh, the contract package that we wanted to um, import, is it actually correct? The syntax 721 um, URIs. URI. Cool. Okay. This one is done. So basically, let me tell you as to what is happening over here. So URI storage.sol, it basically contains the implementation of ERC 721 standard, which is again our what our NFT contract will inherit. Also, to be a valid NFT, your smart contract must implement all the methods of ERC 721 standard, right? So we have done that. But then, yeah, like also even before this would eventually show an error. We have to actually um, declare the license for this as well. So this should be SPDX license identifier MIT. Cool. I think this is correct. Yep. Open Zeppelin contracts token. Callback not supported. Okay. Token ERC21 extensions, and then ERC721 URI storage.sol. Yeah. Also, then we import open zeppelin / contracts / utils / counters.sol, right? And then we need import @open zeppelin / contracts / access / ownable .sol. It should be it. Okay, utils not supported. Counters ownable also not supported. Okay, let me just check as to open zeppelin. Open zeppelin. I think this should be okay. We'll circle back to this a little later, but then yeah. So as to just to let you know as to what is going on over here. So utils.counters.sol basically provides counters that can only be incremented or decremented by one. So whenever so our NFT smart contract is using a counter to keep a track of like the total number of NFTs that is minted by, let's say, set of unique ID, right? So that is why we need counters.sol. What is ownable.sol? So it basically sets up the access control for our smart contracts. So only the owner of the smart contract, that is you, will be able to mint the NFTs. But then yeah, like I'll let you know if let's say you want anybody to be able to mint your NFTs using the smart contract, we will remove a few things from the contract so that everybody will be able to mint, right? But then yeah, like one thing to note is that in MetaMask, only the owners are able to import their NFT. So even though people are able to mint, the contract is actually owned by you. So only you would be able to import the NFTs in your MetaMask for being it for your NFT to be viewable, right? Yeah. So that was just a short note, right? Cool. Now I think we can, now that we have imported everything that we wanted, also let me just change this out, because consider pragma solidity. Oh yeah, we were missing this. Pragma solidity, and then solidity version is 0.8.1.7, right? And obviously semicolon. Found version pragma but failed to parse. Please ensure this is a trailing semicolon. It is 1.7.1. Yeah. Yeah, just typing issues. Now we can move to actually creating the contract. Let me just finish the contract and then we can talk about as to what is going on in each of them, right? The first thing is to just make sure that first contract my NFT. So my NFT is actually what I'm using to as the name of my NFT, right? So we have to make sure, just a second. URI storage. Yep, this looks correct. Yeah. On able. Okay, cool. So we have our custom contract, right, which is which will be surprisingly short, which you'll be able to see. So first we inherited the open zeppelin contracts, which basically implements most of the method to create an NFTs, right, which has like owner of, transfer from, everything. But then what we are trying to do here is basically create our NFT and then add multiple functions to it as to what that NFT will do, right? And what all things it needs. Who also we are defining that only owner is able to mint the NFTs and all those things, right? So using counters for counters, counter, right? And then counters, counter, it takes cool. Yep, it needs to be a constructor ERC7 ERC721 ERC721. Then this is actually the name of my NFT, so it will be my NFT. I'm naming it as my NFT, and this can be just NFT. Right. So this is done. Function mint NFT address recipient string memory, right? And then we would also need the token URI. No, only this much in token URI. Public, obviously, and then yeah, only owner. I'll let you know as to which ones to remove if you want everybody to be able to mint. Let me just complete this 256. Right. Okay. This is done. We need another one over here. Token IDs dot increment. Basically, every time someone mints, the token ID has to increment. That is what we are doing over here. We do this, right? Then unit 256, new item ID is equal to token IDs current, right? And then mint recipient new item ID. This looks correct. And then what we can do is actually set token URI new item ID, and then we have token URI, right? This is done. Then return new item ID. Mint NFT function, address of the recipient, string memory URI. Right. I think now we just have to make sure that we don't have any errors over here and there. So this should be function mint NFT. Why isn't this correct? Let me just check if everything's correct. Token URI and then address for the recipient. Let me just run and format this using Prettier first, and then where is this? format document. Cool. I'm not able to see that option. But then, yeah, before we can do that, cool. So we'll set the errors aside, but then, yeah, I can quickly run down as to what all has happened. Um, right. If you look from line 15, we have a function mint NFT, which basically allows us to mint the NFT, right? And then you can see it actually takes two variables. One is the address recipient, which specifies the address where the NFT will be received, right? And also the string memory token URI. It is a string that basically uh, resolves to a JSON document that describes NFT's metadata, which is kind of important. We'll be making changes to it in the part two, right? Metadata of the NFT is basically what brings it to life. It will have properties, name, properties such as names, description, image as well, right? So yeah, we'll go through that part in the second part of the video. But then yeah, for now we just have to make sure that these errors are gone so that we can move on, right? So constructor ERC721, this is fine. What is the problem over here? Expected this, but then okay. Um, unit 256 return. I think we are missing the bracket. Yeah, it's an issue with brackets. This is your okay. Um, if the prettier was, if let's say the prettier, it is an extension. If it was working, it would have been very fast for us. Let me just check as to what all is going wrong over here. I think this is an extra. Cool. This okay. Okay. What is an issue? Only owner. Um, okay. I think it's an issue. Unit 256. No, wait. It's unit only. Why was I writing? Right. Okay, wait. Yeah, it should be returns rather than return because, okay. Then we have recipient. We have return new item ID. I think the spelling is the issue over here. RICIPI, right? Over here as well, we'll have to make sure the spelling was correct. Cool. I think the only issue was with that, right? Uh, yeah, I think now everything looks good to me. Spelling was the major issue, and also the brackets. Also a little bit on the annotation side. We also missed out on this. We named it as return, which should be returns, right? And UN256 is actually correct, right? Cool. I think now that we have connected this, now that we have created our smart contract, now we can directly move on to the next step, right? Now we have to make sure that our MetaMask wallet is connected to our project, right? How do we do that? So we go to the terminal, right? We have to first make sure that okay. First, make sure that you are in the main directory and not in any of the subfolders of the main directory. So what you do is npm okay, npm install .env save, right? I think this should be correct, right? Let's wait for it. Cool. Now that this is done, what we're doing over here is basically that we are installing a .env package in a project by running npm install.env.save. What we do is we create an .env file in, let's say, the root directory, where we'll make sure that the naming is just .env and nothing else, right? Where we will be adding a private keys to make sure that it is connected to our wallet, so that the project knows who's the owner of the contract, right? We have to make that connection. So right now, I think I'll be stopping my screen share for just a few seconds so that I can add my private keys and jump right back into this. Right. I'll be quickly saving everything as well. Let me just save this, manually save this. Cool. This is saved. Right. But then, yeah, like even before that, let's create an env file first. So new file .env. We'll write it as private key is equal to 0x and whatever private key is there. Now, let's say if you don't know how to export your private keys from your MetaMask, I'll make sure we have it is actually there in the blog. So make sure you're following the blog as you're going along with this video, right? Yeah, so I'll just quickly stop sharing my screen, add my private keys, and I'll share my screen again. Cool. I think I have stopped sharing my screen. Okay. Let me quickly add my private key. Okay. Let me just go to my MetaMask. Okay. I don't have it on the go. Okay. Settings. Okay. Account. Account details. Export private key. Typing my password. I got my private keys. I'll be just putting it over here, saving it, I'll just make sure it is saved. I'll just make sure everything's saved. Yeah, it is off my screen, off this screen as well. I'll be sharing my screen again. I think I am sharing my screen. Yep, looks good. Cool. Now that we have our env file in, right, there we are actually just storing the private key. All now we have to do is that we have to configure the Hardhat config.js. So what we have done till now is that we have added several dependencies so far. Now we have to update hardhat.config.js so that our project knows about all of them, right? So we go to hardhat.config.js. We let this be. We let this be as well. This looks good. Here we just have to actually require .env, enter. This looks good. Once this is there, config, right? Cool. This is done. Now, a lot of networks will be using third-party API service providers, right? We are basically just using RPC config, right? We won't be using any APIs for this as we don't need them. But then, yes, it is always better to use APIs as your private keys aren't exposed, right? Like for this one, I had to stop sharing my screen so that my private keys aren't exposed. But then yes. So network is actually Mantle Testnet. Also, whatever I'm typing over here, it has to be same, right? You can't make changes to it. Is it's the RPC config? It is already been preset. So rpc dot testnet dot mantle dot xyz, right? You can add a slash, comma, then accounts. Here basically we're telling where the smart contract is fetching the account from. So process.env is the file where we have it, and we have actually named it as private key. Okay, wait, not so sure if I've named it as private key or private key. I hope it is all caps. Otherwise, I'll have to unshare my screen and then share it again, right? But then, yeah, this is looking good to me. So hardhat.toolbox config. Yeah, I think everything's good. Let me just quickly save it. I was pretty sure I named this private key. Yeah, I think it should be private key, all caps. Hopefully it is correct, right? Cool, we'll know, right? Now, amazing. Now that we know, that should help our contract know where exactly it needs to deploy on, right? Because we have given the RPC config for the Mantle testnet, it basically knows that now it has to deploy the contract on Mantle testnet, right? Now we move ahead with final stages of this part, which will be the deployment of the script. So let's make a few changes to our deployment script, right? We go to deploy.js. We can see there's a lot of things there. We actually don't need all those, right? But we do need the async main function, right? We'll be making changes in this itself. What we can do is otherwise. Okay, we'll make changes to the main obviously later. So basically now what we are trying to do is first we are trying to define a function which is called main that will handle the deployment of the contract, right? Now inside the main function, the code uses ethers.js library that we are basically using ethers.js, right, to get a contract factory for the contract. And then that contract factory would be like a blueprint that will be used for multiple instances of the same contract, right? So let's go on with doing that. So it will be const, it was my NFT equal to await ethers dot get contract factory. It would be my NFT, right? Here basically we just grab the factory contract, right? Now we start the deployment and then return a promise that resolves the contract object. So const my NFT equal to await my NFT dot deploy, right? This is just okay, wait, equal to, this is just that single instance of the contract, right? Now we have to show as to print as to where the contract was deployed, right? So we can name it as contract deployed to address. Cool. Now to get the address where it was exactly deployed on, my NFT dot address. So using ethos, we actually get to do that. That is why ethers.js is actually pretty cool. Web3.js is amazing as well. We will have some or the other tutorial using web3.js as well, because we've been getting a lot of requests. But then diving back into it, now we have to define our main, right? So basically, in the main function, we are setting up a mechanism to handle either a successful deployment or an error, right? That is what the whole main function will be about. So then, right, uh, process dot exit, yes, 0, yes. Then catch error, yes. Then we'll be choosing this. Then print console dot error. On error, it will print error, right? And then exit of 1, right? Obviously, don't miss out on the semicolons. What declaration or statement expected? Main catch error. Okay, wait. They should be just made. Then process exit. Here, we have too many declarations going on over here, right? So we just need to add these. This, and this should have done it. Where are we adding an extra semicolon? This is correct. We actually needed to close this. Okay. Now expected a comma. Are we missing a semicolon somewhere? Dot catch error. This console dot error. Error process dot exit of 1. Yeah, we can remove this. We had that extra. Cool. I think we're good to go on this as well. Everything looks good to me. Hopefully there aren't any mistakes in spellings, because now we've actually written the deployment script. We have configured our JSON file where we have given the RPC URL. Also, our project knows as to who's the owner of the contract, because we've also imported our private key. And then also we created our own personalized contract using Open Zeppelin as well, where we created the NFT, and then we also attached a few things to it. I'll just make sure that everything is saved. This is saved. Saved. Everything is saved. Cool. Now that everything is done, all we have to do is npx hardhat run scripts / deploy.js, right? We are basically telling it where exactly is the deployment script. And now we have to actually mention is to network would be the Mantle Testnet, right? Okay. And I wrote npn. It should be npx. Cool. I think my screen is visible again. So yeah, like after a debugging session, which I did want to include, obviously because my private key was there as well, I wanted to look as to what was going on. Yeah, so everything was correct. just make sure to follow the code that is there in the blog. There were a few mistakes with packages, right? The name of the packages were here and there. Also, we in the deploy.js function, we were actually including const function for Hardhat, which was actually not involved, which was not required as well. So yeah, I did run npx Hardhat, as you can see, and it worked. We can do that actually again as well. So we just type npx Hardhat run scripts deploy.js, right? I've already deployed it once. Let's do it again, right? Let's wait for it. Yeah, see, you can see contract deployed to address 0x and then 28 something something something. Hopefully my screen is visible. So what we'll do is we'll just open a new window. We'll go to explorer.testnet.mantle.xyz. Let me go there, right? Let me paste it. Cool. It hasn't shown up on our Explorer yet because we've been having so many transactions lately. But let's do one thing. Let's try it for the contract which was deployed a little earlier. I don't think it will be there as well because it was just a few seconds earlier. Oh yeah, it is there, right? You can see the contract was deployed. There was contract creation, success, block 3 minutes ago, right? So you might have to wait for a minute or two for it to pop up, but then everything else should be good, right? So yeah, like that you have it. Congrats, you just deployed your NFT smart contract on Mantle Testnet. After this video, we'll be going on to the part 2, where we will be actually minting the NFT smart contract that we just deployed using code, adding metadata to it, adding images to it, and then all sorts of stuff, right? So make sure that you're watching the next video, and then I'll catch you in the next one.